Hi everyone. Today we're going to talk about laws of logarithms. We have a couple of first things. We know what a logarithm is, so now this is going to allow us to manipulate them a little bit more. We do have some things here. Our base, I think we mentioned briefly, but I don't know that I emphasized before. Our base has to be a positive number. We also don't want our base being equal to 1, which hopefully makes sense because if we're thinking about our log base b of x equals y being b to the y power equals x, if my base is 1, 1 to any power is always just going to be 1, so that doesn't really make sense to talk about. The other thing is we're going to talk about our letters that we're plugging in here being positive. And what I want to remind you of is what our graph of our logarithm looked like. When we graphed our logarithm, we ended up having an asymptote here because this was our inverse of our exponential function. And a logarithm looks kind of like this when you don't have any transformations happening, which means what am I allowed to plug in for x? Well, I'm only allowed to plug in positive numbers. So that's really where this m and n being greater than 0 comes from. It's because of our domain of our logarithm. All right, let's talk about some laws that we have and maybe where these laws come from. I'm not going to go into too much detail where they come from, but I'll liken it to exponent rules that we know. First one here, if we have the log base b of two numbers multiplied together. Well, what happens here is that we can break up our logarithm with addition. The exponent rule that I liken this to is x to the n times x to the m. Well, what do? I add my n and m. So not quite a one-to-one correspondence there with what our rule is. We could show a lot more detail about where that rule comes from. If you're interested, I'm happy to show you. But for now, we're just going to kind of liken it to those so that we have kind of a way to remember them. Well, if I'm thinking about that exponent rule here, and now I have division, but notice I have division inside my input here, right? It's not two logs being divided. It's my input there being divided. This, well, I can break this up with subtraction. And again, hopefully you recognize this as being that rule where when we have our exponents like this, we subtract our exponents. Our last one we've seen a tiny bit of in special cases, and so this is going to let us generalize now. If we have an exponent inside of our input, what we actually are allowed to do is we are actually allowed to put that exponent out in front of our logarithm. All right, now let's take a look at some different ways that we can do these, and let's also liken this to our exponent rules. All right, so if I had given you the problem number 1 here, and I had said solve, let's say on our most recent quest, what I would have had you do is 4 to the k equals this. So let's see, 4 to the k is equal to 16 times 64. Let's see what we would do. We would rewrite the right-hand side so that it was all base 4. So I would have 4 squared, and I would have 4 cubed. And that would mean that over on the right, I would have 4 to the 2 plus 3, which gives me that k is equal to 5. So I get my answer one way. Now, if we're using our laws of logarithms instead, let's see how that changes things. Well, what I'm going to do now is I notice I have two things being multiplied inside my input. So I'm going to split that log up into 2 with addition. So I'm going to have the log base 4 of 16 plus the log base 4 of 64. Whatever I get is going to be equal to k. Each of these individual logs I know, because 4 to the what equals 16, well, that's just 2. 4 to the what equals 64, that's just 3. What's 2 plus 3? Well, I still get that k is equal to 5. So hopefully you can see the similarities in our rule here. This is a little bit of where those rules come from as we kind of go through. Well, same thing here. Let's take a look. 4 to the equals, so the old way, we would have done 4 to the k equals 16 over 64. I'm going to cheat a little bit because I already know from above what 16 and 64 both are. So I have 4 to the k is equal to 4 squared over 4 cubed. And now I can do my rule where I subtract. So I get 4 to the k is equal to 4 to the negative 1, which means k equals negative 1. Well, our new way, using our laws of logarithms, I'm going to split this up, but instead I'm going to split it up with subtraction. The log base 4 of 16 minus the log base 4 of 64. I'm going to cheat a little bit again because up above I already know each of these logs, so I have 2 minus 3. What does that equal? That equals negative 1. So again, we get negative 1 as our answer. We just can go about getting that answer 2 different ways. Last one here. Let's see what's happening with this power to a power situation. 4 to the equals. So 4 to the k equals 16 squared. Okay, let's see. That's 4 to the k equals 4 squared squared. 4 to the k, well, I multiply my exponents here, so I get 4 to the 4th. What happens? Well, k must be equal to 4. With our new rule for logarithms, I am going to rewrite this problem, and I'm going to pull that exponent 2 out in front. So I have 2 times the log base 4 of 16. Well, like all of the other problems that we've done, I know the log base 4 of 16. 4 to the what equals 16? That's 2. So what do I get? Again, I get k equals 4. Good, I better get the same answer, but it's just a different approach. A couple things to notice. First of all of these rules up above, often we go in one direction. You can do all of these rules in both directions. So these are if and only if statements if we're thinking about how to split up or combine. The other thing is that you do need to have the same base when you're doing these. You always want to have the same base because otherwise the logarithms are completely different. You can't combine them at all. Let's take a look at a few more examples and let's split these up. We want to express each logarithm for 4 through 7 in terms of log base 3 of m and log base 3 of n. So we have to completely split up, and I should have like nothing else attached to those logarithms. So on number 4 here, I have kind of a couple different steps. The first thing I'm going to do is I'm going to split up with these two things that are multiplied inside. So I'm going to split the log base 3 of m cubed plus the log base 3 of n squared. Well, that's not enough because I want just a log base 3 of m. I don't want any exponents in there. So now on each individual one, I am going to do my third rule, my exponent rule. I have 3 times the log base 3 of m plus 2 times the log base 3 of n. Sometimes what you'll see is questions that use a sort of substitution. And they'll say, let k equal the log base 3 of m and L equal the log base 3 of n, and express everything in terms of k and L. In this case, hopefully it makes a little bit more sense why you can't leave that 3 up in the top there, because what the heck do I write? It's not k cubed, because k cubed would be log base 3 of m times log base 3 of m times another log base 3 of m. It's only the m being squared, which is why sometimes I do like that substitution instead. When I go and do my rule here, well, now I could write this as 3k plus 2l. So kind of a nice way to think about those ones. All right, let's do a couple more together. Next one here. Sure, there's parentheses. Those parentheses don't mean anything. They're just kind of showing you that your whole entire input here is m squared root n. So I'm going to split it up first. Log base 3 of m squared times log base 3 of n. I don't want the square root of n. I want n to the 1/2 because that's going to then let me do my exponent rule. 2 log base 3 of m plus 1/2 log base 3 of n. And there we go. That would be our answer for number 5. Let's do one more of these together. Let's do number 7. First thing I'm going to do, actually, no, never mind. We'll do both of these. First thing I'm going to do on number 6 here is I'm going to take away the square root and I'm going to have both of these to the 1/2 because I don't want a giant square root. Now I can break this up. Log base 3 of m to the 1/2 minus log base 3 of n to the 3/2. And then I can do my exponent rule, pull my exponents out in front. 1/2 log base 3 of m minus 3/2 log base 3 of n. So be careful with that. You have to be able to split them up. I think we'll skip 7 then, since we did number 6. Let's look at working backwards. These ones I want to combine. I cannot combine until I just have logs. So the first thing I've got to do is move that 2 to be an exponent. So now this is using those rules backwards. I have the log base 3 of m plus log base 3 of n squared. So I can combine those into one logarithm with multiplication. Same thing for number 9. Move your exponents first, then you can combine. The log base 3 of m cubed over n squared. Be extra careful because we are going to learn about logarithm divided by logarithm, but it's easy to get mixed up with your rules. So be extra careful with this dividing rule. All right, last one here. For number 10, I've got to do a little bit more manipulation than I have in the past. First thing, I'll move that as a 6 power, no big deal. This term, though, what I really have is 1/2 times the log base 3 of n. Oh, now that I write it like that, that means that that 1/2 is that exponent. Okay, much better. Let's see what we get. I can combine these into a single log. The log base 3, my numerator will be m to the 6. My denominator will be n to the 1/2. This is okay. I probably would accept this. However, a tiny bit nicer to rewrite as the square root of n, like that. So that one's a little bit better. I like it just a little bit better. All right, and then let's just do a couple of solving problems. For numbers 11, 12, and 13, they gave you the decimal approximation of these and then asked you to find the value. So let's do one of these together. Let's take a look, I think, at number 13, because that one's a little bit tougher. I'm going to first rewrite my 1 over cube root of 2 as 2 to the negative 1/3 power. Now, we could do this our old way, right? We could do 10 to the x equals whatever, but they told us to use the fact that the log base 10 of 2 is approximately 0.3. So I want to get this all in terms of the log base 10 of 2. I'm going to move my negative 1/3 out in front, and then look what I have. I have negative 1/3 times that thing that I know, right? I know what the value of that is. So I'm going to have negative 1/3 times 0.3. Well, if I don't have a calculator, which at some point you might not, I have negative 1/3 times 3/10. So what do I get for my x value? I get about negative 1/10. That would be my answer here. Logarithms are generally irrational, So even though I gave you an estimate for it, logarithms that you don't know are generally irrational, that don't work out perfectly. So I do want you to do that squiggly equal sign here. All right, let's do two more. Number 14 here. I want to solve for x. So the first thing I'm going to do is I'm going to combine my two logarithms. This is a question we could not have done before. The log base 3 of, and I'm going to combine my x and my x minus 6 by multiplying them together, is equal to 3. Now that I have this combined, now I can read off my exponent like before. 3 to the equals, so I have 3 cubed equals, and I'll just multiply out while I do it. That means that I have 0 equals x squared minus 6x minus 27. Well, we know how to solve this. I'm going to factor, let's see, that's going to be minus 9, and that's going to be plus 3. So that's going to give me two answers. I'm going to get x equals 9, or I'm going to get x equals negative 3. But I cannot plug in negative numbers. Remember, we talked about the domain of our logarithm function being all positives. So this answer is extraneous. The only answer to this problem is x equals 9. All right, and then one other one. Let's take a look at number 17 here. I first am going to combine the log base 8 of x plus 1 times x minus 3 is equal to the log base 125 of 25. All right, so I'm kind of stuck at this point. I don't have the same logs on both sides. But what I notice is that over on this side, I actually can evaluate that one. 125 to the what is equal to 25. Well, that's 5 cubed to the what? I won't use x. I'll use w equals 5 squared. That means that w must be equal to 2/3. So my entire right-hand side is 2/3. And on the left, now I can read what my logarithm is equal to. All right, so let's see. Last step here. 8 to the 2/3 is equal to, well, I have x plus 1 times x minus 3.
My PSA is that code generation, you can do it.
I'm going to take the cube root of 8, and then I'm going to square it. That's going to give me 4. Oh, I did the wrong rule. Whoops, hold on. Sorry, everyone.
All right.
Okay, here we go. I'll fix that. Divided by x minus 3, x minus 3, x minus 3. Here we go. Much better. I'm going to cross multiply and divide. So I get 4 times x minus 3 equals x plus 1. And when I go through my solving steps, this is just a regular old equation back from Algebra 1. I get 3x is 13. I get that x is 13/3. My husband was rushing me, so that's why I messed up. I'll blame him. All right, everyone. Thank you. Good luck with these. We'll do more practice in class. And yeah, that's good. All right. Bye, everyone.